record. Okay, so now, good morning. The lecture is
Good morning, sir. Yes, sir.
okay. Welcome everyone. So today we'll start the lecture. Today's lecture is factors affecting efficiency of fans and blowers. So fans are used in various applications in welding machines for cooling the machines, for air conditioning system, etc. Or basically it can be used for cooling the transformers or various machines in which lot of heat is generated. So how can we improve the efficiency of the fans and blowers? So the first important point is we can use the motor which is energy efficient motor. So the motor which is used to drive the blades of the fans or rotor should be energy efficient. It should consume less electricity so that if the efficiency of the motor is ultimately the efficiency of the fan will increase. The next point is the blade speed. The blade speed, we have to optimize the blade speed according to the designer or according to the manufacturer's specification. It gives the specification that at this particular speed the fan works at the maximum efficiency or at particular speed. So we don't have to run the span at a lesser speed or more speed than the whatever is the given speed by the manufacturer, at which the efficiency of the fan is maximum, so that if we keep the blade speed to the particular rated speed, then definitely the efficiency of the fan will increase. Then housing design of the fan. See, this is one more aspect. For example, sometimes there is a blower for cooling the fan and it is fitted in the housing. So sometimes there is a very less space for the fan in the housing and it cannot get some air to blow ahead. So the design of the housing should be in such a way that it will be able to blow more amount of air, and even should not be any leakage of air from the housing. So housing design is the another aspect or another point to increase the efficiency of the fan. See, second point is ultimately same, the clearance between the fan blades and the fan housing. See, if we keep the distance between the fan blades and the fan housing very close, then what will happen? For the fan, it will be very difficult to get the air and to blow it ahead. So we have to keep the optimum distance between the fan and the housing so that it will get the speed air and it will blow ahead the ahead on the part which part is required to be heated. For example, transformer winding, or if the fan is used in the air conditioning system for cooling of the pipes, heat pipes, or sometimes it can be used in the cooling towers for cooling the water. Then another point is clearance. Okay, the next point is blade shape. See, there are various types of blade shapes are available. Various blade shape gives different types of efficiency. Industries have done some research which shape of the blade can give. Sometimes there is a sword shape, sometimes there is a oval shape. So various experiments are being done on the fan blade shape and even the size of the fan, so that it also affects the efficiency of the fans and the blade. Even the length of the blade is also an important aspect. Just like in the wind turbine acts in the very exactly reverse way of that of the fan. In the wind turbine runs when there is a air blowing on the wind turbine, and here the fan exactly works in the opposite direction. It creates the flow of the air. So Rishabh Raj has joined, Rajnish Gupta has joined. These are the new participants. Then, so we are here that the fan exactly works in the opposite to that of the wind turbine. So it creates the flow of air and it extracts the heat from the part on which the heat is blowing. Then second point is cleaning of the fan. The fan should be cleaned frequently. Sometimes what happens, the dust particles are accumulated on the fan, or sometimes if the fan is used in a very, for example, if it is used in the thermal place of the thermal power station. What happens? A lot of dust, dirt particles accumulate on the fans. There is a accumulation of the dust and dirt particles on the bearing section where the fan is being rotated, and there is a obstruction to the rotation of the fan. The fan is not able to rotate precise or accurately or easily, so that we have to clean the bearing, we have to clean the fan blades easily, so that it will blow the air. Fuchsia had joined, it will blow the air easily. And the second point is we have to do the servicing of the fan. Yes, servicing. We have to do the oiling, greasing of the fan, cleaning of the fan. If the some blades are tightened, we have to tighten the nuts and bolts of the blades so that there will not be any much noise. So complete overhauling of the fan and the motor should be done frequently if it is an industrial fan, and if it is overloaded, it's working around the clock, so that frequent overhauling of the fan, servicing of the fan. We can say it is called as preventive maintenance of the fan, so that we have to maintain the fan before it goes for breakdown. So we have to maintain the fan so that the efficiency of the fan will increase. So these are the various factors which affect. If we do not maintain the fan easily, if we do not overhaul the fan, if we do not service the fan frequently, then definitely it will consume more electricity and the output will be less. So there are again various ways to improve the efficiency. The first is change the impeller by hand. What is impeller basically? Impeller is nothing but the fan blades. It's the one kind of rotor. See, in the wind turbine we call it as a rotor, and here it is called as the impeller. Then there are various designs of the impeller. Sometimes the impellers are blades are connected to each other. Sometimes there are different shapes and sizes of the impeller, and the fan manufacturers have done some research which shape of the impeller is more efficient. So what we have to do is we have to replace our current impeller with the highly efficient impeller, and even the particular angle of the blade which is fitted, at which the blades are fitted, is also very important. The amount of air blown on the ahead depends on the particular angle. We have to set the angle at a particular angle as per the specification. Sometimes if the angle is changed, we have to see the angle of the blade so that the efficiency of the fan will increase. Then the next point is change fan assembly as a whole. Sometimes we have to change the complete assembly of the fan. Means, for example, you have to change the bearings, we have to change the we have to change the fan blades, etc. So complete assembly of the fan is changed so that the efficiency of the fan particular blade fan is increased. Then impeller derating by smaller diameter. If we want to increase the efficiency, we can use smaller diameter impeller so as to reduce the load on the motor if our requirement is less, so that the efficiency of the fan blade is increased. That is called as derating of the fan, because if our requirement is less, if the fan is of excess length and there is unnecessary load on the motor, then we can derate the fan, we can feed smaller size impeller, that is the blade length, so that the efficiency of the fan will increase. The next point is change of metallic, glass reinforced plastic. For example, there are various types of materials used in the fan. Most of the time there is a metallic blades are used in the fan. But what can we do? Instead of that, we can use glass reinforced plastic impeller, which is more efficient than the metallic blade, because the glass reinforced plastic blade is lighter in weight, it is even stronger, there is no corrosion takes place, there are a lot of advantages, life is more, and basically it creates lesser load on the motor than the metallic blade, so that the efficiency of the fan, overall efficiency of the fan is increased. So it is the important point that replace the metallic blades by some glass reinforced blade. Prashant Kumar has joined. Then the second point is So it is more energy efficient blade. The next point is fan speed reduction by pulley diameter modifications for derating. Sometimes we are using some pulley, so the speed of the fan is reduced. Sometimes if we do not need more, more speed of the fan, more speed of the air, but so sometimes the pulley is used for diameter modifications or for derating the fan. The next point, option of two-speed motors. Yes, the motor speed is controlled precisely. For example, variable speed drives is used by using some electronic devices like thyristorize devices or MOSFETs or GTOs, so that we can control the speed of the fan. So we are using the converters so that we can control the speed of the fan at a precise value, so that we can change the speed of the fan as per our requirement. So if the requirement is or more air, then we can increase the speed. If the requirement is less, for example, the machine is not much heated. For example, there is a transformer. There is very much less load on the transformer because of the load shedding. And so what can we do? There is less heating of the transformer, so that we can reduce the speed of the fan by using some control, uh, by using some electronic controls, soft controls, and so that the efficiency of the fan can be increased, so that it is called as variable speed drives. For or even we can have variable duty conditions. So what is variable duty conditions? For example, we, instead of running the fan for complete 100% time, because the other had joined, instead of running the fan for 100% time, what can we do? We can switch off the fan for 40% of the time, and we can switch on the fan for the rest of the 60% time, or even for 50-50%. For example, the fan will be switched off for 1 minute. For the next 1 minute, the fan will be switched on, so that there will be less consumption of electricity, and our goal is also served. There is a proper cooling of the transformer also. Or we can change that duty cycle. For example, we can switch on the fan for 2 minutes, and we can switch off the fan by 1 minute by some software program, and it will be automatic switching of the fan and switching on the fan automatically by software program. After every 2 minutes or for the 2 minutes, fan will be switched on, and for the rest of the 2 minutes, the fan will be for the rest of the 1 minute, the fan will be switched off, and again for 2 minutes, fan will be switched on. So that way it is called the duty cycle. We are changing the duty cycle of the fan, and our purpose of cooling the transformer or whatever is the device which is heated is served, and even there will be saving in the electricity as well. Mimic Jan had joined. Then the next point is option of two-speed motors is that we have learned. Option of energy-efficient flat belts. We can or cogged raw edged V belts. Some V belts are there. There is one. It is a cogged blade. So sometimes there are V belts are there. Flat belts are there. So these blades are used, which are energy efficient blades. There is a less reduction in the speed because of the use of the blade. So we have to use energy efficient flat blades or V blades, which are more energy efficient, and adopting inlet guide vanes in place of discharge damper control. Means we have to use some guide vanes, so that the air is projected on the particular part of the air is projected on the particular part of the machine, so that uh, the air will there will be proper cooling of the machine. So uh, So what can you do? We have to use proper damper control. Proper guide vanes are used, so that there will be proper cooling of the machine, and the air will be directed in the particular direction. Then adopting inlet guide vanes in place of discharge. Even incoming air is there in the fan, that inlet guide vanes also we can use, so that air will be accepted by the fan, or incoming air we can control the flow of the incoming control. And in the outlet damper controls, we can use the outer outlet air. So in that way, we can increase the efficiency of the fan, then minimizing the resistance and pressure drop by improvement in the duct system. In the duct system, we can reduce the resistance of the fan, so resistance to the air, so that the proper air will be blown. So these are the ways by which we can increase the efficiency of the fan. So we just revised what are the factors, we just revised what we learned. So I understood what we learned. So let me see the students which are joined. Piyusha Hadke is there, Prashant Kumar, then Prince Singh, Rajnish Gupta, then Rohit Pradeep, Nimit Jain is there, Shresh Sharma, Vikas Yadav. Hello, can you listen to me? Hello, hello.
Yes, sir.
Okay,
Yes,
good,
sir.
good. Students are there. Good, good. Very good. The students are there. So, so what are the various factors? Just let me know what is the topic today? What is the topic today? Let me know so that I will come to know that the students are there listening. Factors affecting efficiency of the fans and blowers. So, what are the factors? So, what are the various factors which affect the and efficiency of the fans and blowers? I will just revise the various points again, so that because we are running out of time, the Zoom works for 40 minutes only. So I'll just revise all the points again. The first point is which affects the efficiency of the fans and the blowers is that the motor. What kind of motor have you used for the blade or for the fan? If your motor is not energy efficient, then definitely your fan efficiency will reduce. So what is our aim is we have to use the motor which is energy efficient. The second point is the blade speed. We have to use the optimum speed of the blade, which is rated even by the manufacturer's specification plate. So the blade speed is also important point. Then the housing design, how the where the fan blades are fitted in the housing and how the housing is designed. The design of the housing is very important. What is the shape of the housing? Then clearance between the fan blades and the fan housing. So what is the distance between the fan blades and the housing? If there is very, very less distance between the fan blades and the housing, then what happens? The fan is unable to extract the air from the housing. So there should be some minimum distance between the fan blades and the housing. So that is one of the points. Then the next point is blade shape. So the blade shape also decides the efficiency of the fan. There are various shapes of the blades available. For example, some innovative research manufacturers I use sword-shaped blade or some oval-shaped blades, or even they have tried different lengths of the blades. So the blade shape of the fan also affects the efficiency. The second point is cleaning of the fan. Sometimes what happens if we are using the blade of the fan in the thermal power station or where there is a lot of dust and dirt particles are there. So what happens? The dust and dirt particles accumulate on the fan blade and even on the bearings, on the rotating parts, and it creates some obstruction for rotation of the fan, and therefore the efficiency of the fan is reduced, the fan is unable to rotate, the noise is produced. So we have to clean the fan frequently. The next point is servicing of the fan. If we do not do the servicing of the fan or even overhauling of the fan, we have to do the frequent servicing of the fan so that the efficiency of the fan is increased. We have to change the grease, we have to change the bearings, even we have to overhaul the fan, we have to tighten the nuts and bolts of the fan so that the efficiency of the fan is increased. Even we can change the impeller, which is highly efficient. Instead of earlier impeller, we can change the impeller so that the efficiency of the fan is increased. The impeller is nothing but the blade. It is a blade, it is another name to the blade. Then change the fan assembly as a whole. Sometimes complete fan assembly changed along with the bearings, etc. So the efficiency of the fan is increased. Then impeller derating. Sometimes smaller size impeller is used, means the load on the motor is reduced so that It consumes less electricity because the requirement of the air is less. So by reducing the diameter of the impeller, the efficiency of the fan is increased. And the next point is replace the metallic blade by some glass reinforced plastic blade. So what happens? What are the various advantages of glass reinforced plastic over the metallic blade? The glass reinforced plastic, Pradyum Tyagi has joined. The glass reinforced plastic is lighter in weight and even it is resistant to corrosion. It is very strong, and so that what happens, it creates a very less load on the motor and the efficiency of the fan is increased. So this was also one of the points. And the next point is sometimes we are using pulley to modify the diameter or for derating of the fan, and then sometimes we use two-speed motors or variable speed drives. That is, we can use the various converters using MOSFETs, IGBTs, thyristors, which is a silicon control rectifiers, SCRs. So we can have a converter so that we can change precisely the speed of the motor by changing the angle of the silicon control rectifier or SCR so that the speed of the motor is changed precisely and there is a less power drawn from the fan. Then sometimes we are using two-speed motors that we have learned. Then so we have to use energy efficient V blades or some flat blades. Sometimes what happens because of the blade efficiency is reduced. So we have to use energy efficient blades, cog blade belts are used. Then adopting guide vanes, inlet guide vanes. So it will control the incoming air and sometimes outlet guide vanes which will control the outlet air. Means the air will be blown particularly on the particular part of the machine which is to be cooled. For example, the transformer fins, cooling tubes. So we have to focus the air on the particular part of the machine which is to be cooled so that the efficiency of the fan is increased. So these are the points what we learned. So actually we'll just stop the lecture up to this point. Thank you very much for joining the lecture. So thank you. I will just see which are the students. Ph.D. is there, Prashant Kumar, Prince Singh is there, then Rajnish Kumar, Nishchal Sharan had just joined. So Prashant Kumar, Ph.D.
Thank you, sir.
Okay, good. Then Rajnish Kumar Gupta, Rohit Pradeep, then Rohit Pradeep is there, then Pradyum Tyagi is there, Nimit Jain, Vikas Yadav. So these are the students present for the lecture.
Sir,
So
present.
thank you very much for attending the lecture. So we'll stop the lecture. You can see the
Sir,
lecture.
Sir Nishchal Sharan.
Yes.
sir,
So that
sir,
Okay.
yes.
sir,
Nice.
You can see.
kindly share the sir notes, sir,
Yes. I will definitely provide you notes on the edX
before UT,
platform.
sir.
I'll put all these notes on the edX platform so that you will be able to see the all lecture again, and even I will provide the recording of the lecture on the edX platform so that you'll be see and listen to the lecture again. Even those students who are not present, they also will be able to see the lecture. Thank you very much.
Yes,
And
sir.
Thank you
Thank
so much.
you. Sir,
Thank
send
you,
us
sir.
the paper, sample paper.
yes, definitely I will provide you all kind of material, notes, lecture, everything I will provide. Thank you very much. We'll stop the lecture.
Okay, sir. Bye,
Thank
sir.
you very much.
Bye
Thank you,
sir. Bye
sir.
sir.
Bye bye, sir.
Thank you
Have a
sir.
nice day.
Thank you
Have
very
a nice
much.
day, sir.
Thank you sir.